Welcome to The Explainer. Today we're diving into a pretty radical new idea for the future of AI. The argument is that we shouldn't just be building bigger and bigger models, but we should be totally rethinking how they're built from the ground up. This comes from a really fascinating technical discussion, so let's get right into it.
All right, let's start with something I know you've run into. You're maybe 10 messages deep in a conversation with an AI, you've laid out all this context, and then suddenly, poof, it completely forgets a key detail you mentioned just a few minutes ago. It is so frustrating, right? Well, that little annoyance actually points to a massive, fundamental problem with how AI works today.
But what if I told you the problem isn't really the AI's memory? What if the problem is how we're trying to make it remember in the first place? The source material we're looking at today makes a bold claim. We've been tackling this entire challenge from completely the wrong angle.
See, right now, we are stuck in this loop of just trying to cram more and more text, more words, more tokens into the AI's short-term memory, hoping it'll stick. But the real goal, the real breakthrough, isn't about preserving the text. It's about preserving the AI's internal train of thought.
Now, this train of thought has a technical name. You'll see it here, the hidden state trajectory. Yeah, it's a bit of jargon, I know, but the concept is super powerful. Just think of it as the unique path the AI's internal logic carves out as it makes sense of information. It's the actual shape of its understanding, not just the words it read.
And this is a huge paradigm shift. The old way, preserving text, is kind of like trying to memorize a whole book, word for word. The new idea, preserving the trajectory, is like actually understanding the book's plot, its characters, its themes. One is just brute force memorization, the other is real comprehension. And as you can imagine, it's way, way more efficient.
Okay, so if preserving this trajectory is the goal, that sounds great, but first you have to be able to measure it, right? And that's where we slam into a wall, a mathematical problem that is just staggering in scale.
So trying to measure the difference between two of these internal trains of thought is unbelievably complex. I want you to imagine trying to compare the exact position of two objects, but in a space that has like billions of dimensions. It's computationally hopeless with the tools we have today.
And the source itself puts it really bluntly. The sheer scale of this measurement problem makes it feel like we're just stuck, waiting for some massive, fundamental breakthrough in mathematics just to even get started. It really does feel like an impossible task.
But, and this is the really clever part, the big insight here isn't to solve that impossible math problem head-on. No, it's to find a super elegant way to just sidestep it completely.
The breakthrough idea is realizing that we don't actually need to compare the AI's internal state directly. Who cares, right? What we really care about is whether two different internal states end up producing the same results in the future. It's all about the output.
And that leads to this beautifully simple test. You take your original, long-winded context, and then you take your new, super compressed version of it. You give both of them the exact same test prompt. If they both predict the same next word, guess what? They're functionally identical. You've successfully compressed the AI's train of thought without losing anything important. It's genius.
This elegant method has a name too. It's called measuring predictive divergence. So instead of wrestling with that insane billion-dimensional vector, it collapses all of that complexity into a single, clean, manageable number that asks, how different are the future predictions? And just like that, the impossible problem becomes totally solvable.
So, with that one brilliant little workaround, a whole new way to design AI systems just unlocks. A more powerful, more logical architecture for machine reasoning.
And this brings us to a completely new way to build these things. Forget today's giant, monolithic models, where logic and memory are all chaotically tangled together. The future, this paper argues, is a small, efficient logic core, maybe only 1 billion parameters, that's dedicated to pure reasoning. And that core consults a separate, massive external memory. Think of it like a brilliant professor who uses a giant reference library.
And the advantages here, they're huge. A smaller reasoning core is just naturally more stable, less chaotic. It forces a clean separation between the act of thinking and the act of remembering facts. We can stop fighting the brittle, unpredictable mess inside a giant model, and instead, we get a system that's clean, efficient, and something we can actually inspect and understand.
And this really is the central paradox here. It's so counterintuitive. To build a more capable AI, one with a truly powerful memory, you don't build a bigger brain. You actually build a smaller, more focused one, and then you give it a library card.
Now, this new architecture doesn't just change how an AI thinks on the inside. It completely upends the very way we interact with it on the outside. You know, we've all gotten so used to the simple back-and-forth chat window. It feels like a conversation. It feels natural. But the argument here is that it's really just an illusion. It's a clever trick that hides the flawed one-way process that's actually happening underneath the surface.
Because the absolute foundation of modern AI, that simple act of predicting the next word to complete some text, what we call chat completion, is, according to this argument, a really poor substitute for what we would actually call reasoning. It's an abstraction that's holding the entire field back.
So why is it flawed? Well, because real thinking isn't a straight line, is it? We backtrack, we revise our assumptions, we refine our ideas. Chat completion can't do any of that. It's just a one-way street of generating text. It only simulates thought because the words appear over time, but it's not really thinking.
And all of this leaves us with a final, really provocative question. If the chat window that we all use today is a dead end, if it's just a simplified illusion of thought, what comes next? What is the true interface for a machine that can actually reason? That's the challenge that this new architecture forces us all to confront.